One way of making a computer quicker is increasing the speed of the CPU. There is a limit as to how much we can do this by, and we think we are soon going to reach it. Another way of speeding up a computer is by having more processors working at the same time. When we have more than one processor on the same chip, we call these processors cores. So a processor with 2 cores is a dual-core processor, and a processor with 4 cores is a quad-core processor. You may notice some processors with 3 cores in them. These are often quad-core processors with one of their cores disabled. When we have a multi-core processor, if we have multiple pieces of software, different cores can handle different programs. It is also possible for several cores to work on the same program. We call this parallel processing. For example, let's look at trying to find the total of an array of 1000 numbers. In a single core processor, the algorithm would look like this. When we run this program, the for loop has to run 1000 times for us to get our total. But how about if we use 2 cores to solve the same problem? This time we could use an algorithm like this. This time, one core runs a for loop 500 times to add the first half of the array, and at the same time as it is doing this, core 2 runs a for loop to add the second half of the array. This means we can complete the task in almost half the time. The more cores we have, the quicker we can run the program. So with 4 cores, we can run in nearly a quarter of the time. 8 cores, nearly an eighth, and so on. An algorithm like this is the best case scenario. Not all algorithms can have their work divided so easily. Where an algorithm requires the outcome of a previous step before it can move on to the next step, adding extra cores will not give you any benefit. Let's take an example of calculating the Fibonacci sequence. In the Fibonacci sequence, we get a term by adding the 2 terms before it. So if we start off with 0 and 1, the next term will be 0 plus 1, which is 1. The next term is 1 plus 1, so 2, followed by 1 plus 2, which is 3, and so on. A program to print the first 100 terms of the Fibonacci sequence would look something like this. Each term in the sequence needs to know the terms before, so there is no benefit from sharing it amongst several cores. In reality, most problems tend to have some parts that benefit from parallel processing and some that don't. Having more cores in a processor can make a computer run faster, but having 2 cores will never be as fast as 1 core running at twice the speed. In this video we have learnt when we have more than one processor on the same chip, we call them cores. Dual-core processors have 2 cores and quad-core processors have 4 cores. Multi-core processors can improve performance when running several programs at the same time. Some programs can have more than one core working on them at the same time. The increase in speed depends on the type of problem.